Hello, this video will talk about the determination of the sum of the roots of the following quadratic equations. In order for us to determine the sum of the roots, definitely we need to understand what are the roots of these 5 quadratic equations. However, we could automatically get the sum of the roots given by this formula. The sum of the roots of a quadratic equation is simply the result when we substitute negative b over a. This formula was taken from the derivation using the two roots that you could gather using the quadratic formula, which is in the form of negative b plus minus square root of b squared minus 4ac all over 2a. Take note that this is the quadratic formula that will allow us to get the roots. But if we are going to add the two roots that will come up from this second term, which is the discriminant having plus, minus, or opposite signs, will be simplified to 0, and you will have negative 2b because you're adding two negatives, and then 2 will be divided to that. That's why you will get this formula. This is now what we are going to use, that instead of having the roots first, we can automatically solve the roots, or the sum of the roots rather, of this given quadratic equations. The derivation may be given to you later in a separate video. But for this practice exercise is concerned, let us try to determine the sum of the roots of these 5 quadratic equations. Again, we simply use b and a coefficients in the standard form of quadratic equation. Hence, what needs to be done is first to identify the correct a, b, and c coefficients. In this given quadratic equation, the a coefficient is 1. It is the leading coefficient, or the coefficient of x squared. B is the coefficient, or the numerical coefficient of the middle term, or also known as the term with x variable, or literal coefficient. This minus 81 is not the b coefficient, but it's rather the c coefficient, since it's the constant in the given equation. Hence, our b coefficient is 0, or in short, it's not present here. Before we go to solving the sum of the roots for this item, you need to understand that for the c coefficient, even if it's not to be used here, our c coefficient is correctly known as negative 81, as it uses the operation before as its sign. Let us now solve for the sum of the roots of this quadratic equation, even without knowing what the roots are. Negative b over a. And our b is 0, so the negative of 0 over 1, which will just give us the result for the sum of the roots being 0. If you are not convinced with this, we could of course solve for the roots of this using extracting square roots, where we transpose this on the other side, and we will get x squared equal to positive 81. And if you're going to take the root of both sides, you will have positive negative square root of 81, which will give you positive negative 9. And if we are going to add positive and negative 9, we will still get 0. Again, this is just for illustration, but we don't need to solve for that, since our goal is only the sum of the roots, and we already have this formula. Let's proceed to number 2. Again, let's determine the correct a and b and c coefficients. A here is 1. B, on the other hand, is now identified as negative 4. Unlike in number 1, where 81 doesn't have any literal coefficient, here 4, or specifically negative 4, is the numerical coefficient of the middle term with x, and hence it's b. If we are to continue, c is actually 0. Again, we don't need c here because our formula only involves b and a coefficients, specifically negative b over a. But still, it's the purpose for this is to practice identifying the correct coefficients, hence we show c. So to move further, we have this next step. The correct step here is substitution, and we need to substitute properly. Take note that the formula is negative b, so you'll have negative and whatever would be the value of b, and since our b is negative, please enclose it in parentheses. It's incorrect to say negative 4 over 1 because this means that your b coefficient is positive 4 as the formula already indicates negative sign. Since our b coefficient is negative 4, we need to use this parenthesis, and this would be divided by a coefficient which is 1. Here, we will use the double negative property to make it positive 4 over 1, and hence the sum of the roots is positive 4. Similar to item number 1, if you're not convinced with this, you can solve for the roots of this quadratic equation and add those roots, determine if this is the correct answer. But we are not going to show it in this video. Let's proceed to number 3. And we have here 3, 4, 5, which are considered to be complete quadratic equations since it has a, b, and c coefficients. But nevertheless, you will not be using c, but let's just show this anyway. A is 1, b is 4, and then c is also positive 4. So these coefficients will be used to determine the sum, which is again in this formula. Sorry, that's S is equal to negative b over a. And here, our b is positive, so simply place here the negative of the value of b, which is 4, over 1. Our a, in short, the sum of the roots would be negative 4. Again, you could verify that by looking at the roots of this and add those two if you will still get the same answer. For number 4, the correct coefficients, a equals 1, b equals 4, and c 5. Notice the difference between number 3 and number 4. The only difference is the constant here, or the c coefficient, being 4 in number 3 and 5 in item number 4. However, again, we will not be using c. In short, we are expecting to use the same a and b coefficients, and we are expecting that the sum would be the same for both number 3 and number 4. So let's continue this. You have the negative of b, which is 4, over 1, which will give you the same value for the sum, which is negative 4. See, we have the same results even if the constants are not the same, since the coefficients to be used are just the same for both numbers. Last number here, number 5. And we are lucky to have a coefficient which is no longer 1. So to test our skill, a is 2, b is negative 8, and c being 3. The formula for the sum of the roots is given to us by negative b over a. Notice that our b is already negative, so again we enclose them in parentheses, or it rather, in a parenthesis, over 2, which is the value of your a. So you will have the result of positive 8 using the double negative property over 2. In short, the sum of the roots of this quadratic equation is positive 4. Again, you can still verify this when you get the value of the roots and add them up. see if it results to 4. This is the content of this practice exercise, as this only includes the determination for the sum of the roots of the given quadratic equations. Thank you for watching. Goodbye, everyone.